There are many theories surrounding the origin of the universe and its fate. Now, we will look at how our star system possibly have formed and later, how the planet harbored life. Specifically, by the end of this lesson, you will be able to explain how the solar system came about, describe the characteristics of Earth that are necessary to support life, and explain that the Earth consists of subsystems across whose boundaries matter and energy flow. As the universe settled from immense heat, the universe remained a desolate place. Some stars were forming, along with some other celestial bodies like planets, thus was a dangerous place for anything. Encounter hypothesis is one of the hypotheses on the origin of the solar system. It explains that 5 billion years ago, when the Sun was all alone in the cosmos, a rogue star passed too close to it, stripping out enormous amounts of matter. Due to the immense gravitational pull, matter was ripped as debris from the Sun. As the rogue star left, gravitational pull became less and matter started to swirl around the Sun. Debris collided with each other, which gave them chance to clump up together, forming the planets and asteroids revolving in the same direction around the Sun. Nebular hypothesis does not go far away from the Big Bang theory. Based on this hypothesis, as the universe cooled down, large gaseous clouds contracted due to self-gravity, forming a star on its center, and its surrounding body rotated due to conservation of angular momentum, where planets and other bodies in the solar system formed around it. While protoplanet hypothesis is currently the working model of the solar system. Protoplanet hypothesis is based on the nebular hypothesis. As concentrated chunk of gas cloud from the universe contracted, the Sun was born, and as it settled, the planets formed around it. In the protoplanet hypothesis, it explains that planets formed based on the temperature gradient in the solar system. Warmer areas near the center allowed terrestrial planets to form as higher temperature vaporized most of the compounds, forming denser and rich planets. While on the other hand, gaseous planets formed volatile, icy, and gaseous. Life on Earth depended on the presence of liquid water and right amount of heat, allowing flora and fauna to thrive. The planets also formed through accretion of gaseous materials, just like how the Sun was hypothesized to form. With the right minerals and heat, it allowed Earth to form an atmosphere. Thanks to an active geologic activity, rich water and rich bio-supporting materials like oxygen, nitrogen, carbon, and hydrogen allowed life to exist. The position of the planet in the Goldilocks zone or the habitable zone also contributed to the existence of water and relatively thick atmosphere, as the Goldilocks zone is an area in space where it receives the right amount of heat and radiation from the solar center. Heat from the planet comes from two sources. The first one is from the radiogenic heat from the Sun. This radiation is trapped by the layer of gases called the atmosphere. The second source of heat is from our planet, which also comes from radioactive decay of materials from the core and mantle, extruding energy through tectonic activities. Heat is essential as it drives many systems necessary in supporting life. The atmosphere is vital in keeping the greenhouse effect, along with allowing various weather conditions and protection against harmful radiation from space. The heat from the Sun, driving and influencing the planet, calls the Earth as having an open system. Though for it to be called an open system, there should be a significant exchange of energy and matter between celestial bodies and the planet. The planet is a closed system, allowing for exchanges to happen between and among its subsystems. This means that whatever happens to one system has a significant effect on the other. The subsystems are the atmosphere, the biosphere, the geosphere, and the hydrosphere. These four subsystems are linked through biochemical cycles which highly affects how the planet supports life in the first place. To recap, you learned about the hypothesis of the origin of the solar system, the characteristics of Earth that are necessary to support life, and the Earth consists of four subsystems across whose boundaries matter and energy flow. For your takeaway, remember how special you are. We haven't found any life away from our planet, and yet here we are. A mere speck of dust from an unknown source placed in the right conditions in the universe and in the solar system, in a body on Earth that is able to think and is self-aware. This is how special we are. Thanks for watching, and I appreciate your time. See you on the next one.